Welcome to Season 5 of AIHA's podcast series, The Healthier Workplaces Show, where we explore timely and informative topics about occupational and environmental health and safety. I'm your host, Alejandro Castillo. Today, I have the pleasure of speaking with Industrial Hygienist Dr. James Johnson. Dr. Johnson is a retired industrial hygienist and qualified environmental professional with more than 5 decades of experience in occupational safety, health, and respiratory protection. He has contributed extensively to national safety standards, research, and consulting related to hazardous materials and personal protective equipment. Since 1978, he has operated JSJ and Associates, a consulting firm focused on occupational safety and health issues, with particular emphasis on respiratory protective equipment programs and the effective use of PPE in complex work environments. Dr. Johnson earned a Bachelor of Arts in Chemistry from Indiana University of Pennsylvania in 1967. He then continued his graduate studies in Pittsburgh, earning a PhD in Inorganic and Organic Chemistry from Duquesne University in 1972, along with a Master of Science in Hygiene in Air Pollution and Industrial Hygiene from University of Pittsburgh in the same year. Today's episode is part of our Luminary series. We're going to talk about Dr. Johnson's 40-plus years in OEHS and learn about how the OEHS industry has changed since he started his career. Dr. Johnson, thank you for joining us today.
It's my pleasure and honor to be part of this program.
Let's start from the beginning. How did you discover OEHS and what made you become interested in this field?
Well, it's kind of an interesting background where I essentially stumbled onto it. My initial focus was chemistry, so I was working on and finishing a doctoral degree at Duquesne University in Pittsburgh, Pennsylvania, and was ready to go out and find a job. And after submitting 50 resumes, the only offer I almost got was the morgue in Toledo, Ohio. And I thought, this just isn't going right. And so one of my chemistry professors recommended I look at the University of Pittsburgh Graduate School of Public Health for a program in air pollution at that time. So I went out, reviewed it, applied, was accepted, and started in September of 1971 while I was still enrolled at Duquesne finishing my doctoral dissertation. So I was able to continue both academic commitments. And then in February of 1972, a recruiter, industrial hygienist, and it was February, it was snow, and it was just miserable in Pittsburgh, showed up and wanted to interview a few students for possible internships for the summer at the Lawrence Livermore National Laboratory. I was asked to go down and meet with him. Short story, I looked it over. I was offered a summer internship, and we packed our bags after I finished my doctoral dissertation and took enough information to work on my master's thesis at Livermore. And we were off the end of June for a new adventure in California. So that started my career at the Lawrence Livermore National Laboratory. And during the summer, I was able to tail along with the industrial hygienists in the program there, realized what industrial hygiene was, how exciting, how different, what a variety of challenges and work that was available. So I was offered a full-time position in September, and I took it, and that was my job.
Now, as a field industrial hygienist, what were your first responsibilities and what problems were you addressing?
The laboratory arranged its safety program in support teams, safety support teams, and there were 5 of them that supported different major programs at the laboratory: chemistry, physics, engineering, weapons, and then biomed, and then the institutional program. I was assigned chemistry support So I got to interact with a variety of chemists who were working on high explosives, adhesives, degreasers, coatings, and other components that or other activities that supported the nuclear weapons program at the laboratory.
So in other words, you were never not busy, of course.
You know, that was probably the most exciting part of the job, is that there were so many interesting opportunities that I can remember my boss one day called me in, and he was an animated Italian industrial hygienist. And he sat me down and he was working his hands actively. And he said, Jim, in the morning, I want you to practice this. Say no 3 times in front of the mirror. Get used to saying no because you're doing too much. So yeah, there was lots to do, a lot of exciting challenges, and it was really a delight to be able to work in that environment where you're always learning new things and interacting with some of the best minds in the country at that time.
In 1978, you founded JSJ and Associates and have operated for decades. What inspired you to start your own consulting firm while working in the field of industrial hygiene?
I like that question because I hadn't thought about it. And for me, that opened the door into a wide variety of industries out in the real world, so to speak, that had industrial hygiene problems. At the laboratory, there were problems, but we had unlimited budget, great facilities, and were able to correct things immediately. Whereas when you get out into the real world, there are different conditions and different experiences. The first job I recall I had was evaluating a sewer pipe explosion that resulted in a fatality and trying to help figure out where the explosive gas came from. Another project that came to mind when I was thinking about experiences was dealing with a depleted uranium catalyst at an Exxon facility in the Bay Area. And so we had to put a control program together to make sure it was extracted from the catalyst tubes properly, and the new catalyst was put in, and the dust and residue was properly disposed of. That led us to an opportunity. There were several of us that worked on that, to go down to Aruba, out of the country, to a old Exxon refinery that was used in World War II to refine benzoyl and crude oil to provide a major part of the aviation fuel for World War II. The last one that jumped out, just to show the variety of opportunities I had looking out into the real world, because I got a job down at Diablo Canyon, which is a nuclear power plant on the Central Coast in California. And in the early 80s, they realized that the engineers had used the wrong mirror image of the reactor design for the second reactor. So all of the supports and piping were put in backwards. So that resulted in a major retrofit of the piping, welding in confined spaces, and all kinds of interactions which required temporary ventilation, monitoring, and working with welders to make sure they carried out the work safely. And the last one I'll mention was a program I set up for the polishing of the James Webb hexagonal components of their mirror, which were solid beryllium. So they had to be polished to a certain high tolerance and curved. So each component, and there were 18 of these hexagonal mirror components that were around 4.3 feet in diameter on big polishing machines, slowly providing them the right curvature to be ready to go into the next step of the design. So just interesting to see what was available in the Bay Area where industrial hygiene support was needed, and gave me a real challenge to make sure things were done safely.
Absolutely. I mean, no day was the same, it sounds like. Every day was a new adventure.
Of course, the lab always, I always say they could do anything they wanted there because they had an unlimited budget, and all we had to do as the safety teams is make sure they didn't hurt themselves or blow anything up or create any big problems.
Of course. Now, in the 1980s, you served as a safety science group leader in the Special Projects Division. What kinds of research projects were you and your team working on during that time?
That was when I transitioned now from a field industrial hygienist over to what I really enjoyed was health and safety / industrial hygiene research. So in that role, this group focused on industrial hygiene needs within the laboratory and overlapping out into the rest of the country or other DOE facilities. So one of the big things that I ended up spending a large amount of my time on was respirator research. And how do you fit the respirator? How do you make sure it fits the worker? And how do you improve performance? So we did a lot of work on fit testing and evaluating half mask, full face masks, self-contained breathing apparatus. And then we had a project where we were looking at breakthrough of organic vapors in carbon cartridges, which allowed then the calculations of the breakthrough time. I got on an ASTM F23 committee on glove permeation. So we spent a fair amount of time, or I was involved, measuring the permeation of various polymers and making sure that the right glove polymer was selected for the chemicals the protection was intended to provide. I also got involved with total encapsulating suits and looked at how crude the initial suit applications were and how they were maintained. I can remember I went to a facility in New Jersey to look at total encapsulating suit program, and it turned out the staff, the health and safety staff, had turned over the maintenance and distribution of these suits to the janitors.
Oh, wow.
And these were life-saving devices that needed to be carefully watched, checked, and that's if you're not paying attention, that's where some of these programs can evolve to. So we did some testing on suits, and overall that the chemical suits that are now available are a lot better, and the disposable suit has entered into the market and makes it easier so you don't have to deal with decontamination when you have toxic materials involved. And then we looked at instruments that were used to measure respirator performance, the port account. On an OSHA contract, we ended up working for some outside government agencies to help take advantage of our capabilities to help their programs. And we also spend some time, a lot of time, trying to figure out how to improve filter performance using electric charge, electrostatic charge. So that kept the division, or that operation in the safety science group, very busy. And of course, you have to chase the money to make sure there's enough to cover the staff and go about the work and facilities and equipment. But that all worked together to allow us to enjoy a lot of exciting times.
Serious incidents and fatalities still occur in organizations with strong safety programs. Join the Controlling Serious Incident and Fatality Risk, using systems framework with ASTM standards to identify, prioritize, and reduce SIF risks. Live virtual PDC on June 17th and earn 3.5 contact hours. Register today to learn more.
In the late 1980s, you joined the National Fire Protection Association. You directed several research projects that resulted in the development of the first NFPA 100-liter breathing machine and the NFPA flame and heat test apparatus. Can you tell me more about these developments and why they are so important?
Well, you got to look around the country and realize if I was in the safety business, I'd probably say tree trimming would be something. I see the guys up trimming trees, and I really respect and admire that group of workers, because they're, as far as the safety business, in one of the most hazardous operations going. In industrial hygiene, I would say the fire service and the fire departments and the individual firemen are working in one of the unknown hazardous environments we have. And it is also very demanding because of the heat. And, the last 20 years I've watched, after I've gotten out of this business, to see how the focus is now looking not as much at the thermal exposure. That's been pretty well handled. It's now all the toxic residue and exposure the firemen are getting from the fires. So one of the key issues when I was starting out in this area was a self-contained breathing apparatus, another respirator. And we had in the hazards control department our fire department, which had two sites, one on the main site and then one out at a remote high explosive and experimental test facility in the hills east of Livermore. And so that meant we had kind of routine kinds of responses, as well as wildfires from the grassland at the remote site. Now, I was lucky in that there were two fire chiefs in my career working and supporting them, that were really interested in improving equipment that the firefighter wore. At that point, the main area of interest was the self-contained breathing apparatus, the SCBA, but the mask, the full face respirator, the hoses, the gloves, the turnout coat, and boots were also eventually evaluated and taken a look at. The one thing, just to show you how bad it was, when I first got in there and started looking at the equipment, there were stories about firefighters that were in high thermal environments. They'll call them a flashover, where there'll be a gas buildup, and at some point an ignition, and then there's an explosion, and essentially a flamethrower, a flashover comes out on these guys while they're in the buildings. Now, one of the stories, or a number of the stories, where one manufacturer was using polypropylene straps, shoulder straps to hold the equipment on, and the polypropylene melts. And so here's a firefighter trying to get out with his life, and his backpack falls loose because the straps holding it melted. And that was a widely used piece of equipment at the time. They were always short on air because NIOSH tested the equipment at 40 liters a minute and said that it has to meet 30 minutes at 40 liters a minute. In looking at high work rates for firefighters or any worker, it's not unusual to see sustained 100 liter a minute breathing rates when they're really working hard. So they could take a 30-minute bottle and, as they would say, suck it down in 10 to 15 minutes. And they're just in the middle of the fire, and their warning bell goes off saying, you got to get out of here, you're running out of air. That created a problem where we needed to first be able to measure high flow values on SCBAs so they could be tested and approved for that high volume. So that's why we designed and manufactured what we called a 100-liter breathing machine in our shops that then became an example or a piece of equipment included in the NFPA SCBA standard for a number of cycles till they improved the design and made it a lot easier with the electronics and bellow pumps to operate. Because of this deficiency in the NIOSH 40 liter a minute standard, it was quickly realized that new technology needed to be put together to get the firefighters more air and lighter weight bottles than the heavy steel aluminum bottles that they were currently carrying. So an aluminum fiber wrapped bottle was developed, and a high pressure bottle that took the pressure in the breathing air bottle. The old one was, let's see, what was that? That was about 2,216 PSI up to 4,500 PSI, and essentially almost doubled the amount of air the firefighter could carry on his back in his tank, and the weight was less. So that was a major innovation that came out to improve the self-contained breathing apparatus. And the 100-liter breathing machine then allowed the testing of these various devices with the regulator and the headpiece to make sure it worked properly and could be approved as an NFPA compliant apparatus. You know, an amazing breakthrough for the firefighter, because any weight that you can take off of those guys' back, the better they're going to perform, because they're normally carrying, with all their equipment and gear, 40 to 50 pounds. And, you know, if you've done any backpacking or gotten out with some weight, you can really appreciate the significance of a 40, 50-pound pack on your back. Now, the next piece of test apparatus we developed was the flame and heat test. And this was needed to be able to qualify the NFPA SCBA that it would survive a flashover. And that would be a thermal soak at 500 degrees for 5 minutes, and then a 10-second 1800 degree flash, which again is simulating the firefighter working in a hot environment, 500 degrees, 5 minutes, and then a flashover for 10 seconds at 1800 degrees Fahrenheit. And then after that, the device is dropped 6 inches to make sure it doesn't fall off the test mannequin, simulating what it might do the firefighter. And the breathing rates are 40 liters a minute in the 5-minute 500 degree test, and then the 1800 degree Fahrenheit test for 10 seconds. It's ramped up to 103 liters per minute. And the face piece needs to stay negative. That's the pass fail, as well as anything that catches on fire, a hose or whatever, is self-extinguishing. And in the meantime, what these poor firefighters were going through is at some points their mask would glaze. And in some cases, the polypropylene would melt. So here you are, depending on your breathing air coming and visibility coming through that face piece, and it crazes so you can't see out, or in some cases it starts melting and the air starts really leaking out of the mask. You can see the trauma that this would introduce to the firefighter who's just trying to do their job. So this flame and heat test allowed the equipment to really be tested real time and in realistic conditions, and it had to perform to meet the standard.
General registration for AIHA Connect 2026 is officially open, and we're heading to one of America's most vibrant cities, New Orleans. Don't miss out. Register now.
Absolutely. Now, from 2000 to 2006, you became the section leader of the Chemical and Biological Safety section at Lawrence Livermore National Laboratory. Why was the CBS section created? And looking back, what accomplishments from your time leading that section are you most proud of?
So the Chemical and Biological Safety section was really the combination of all of the industrial hygiene functions that were dispersed in the Hazards Control Department. So the Industrial Hygiene Group was put in the Industrial Hygiene Analytical Laboratory, the Industrial Hygiene Instrument Laboratory, and the Respirator Program Facility were all put into the Chemical and Biological Safety section. Now you might say, that's weird, why is biological in there? Well, the surprise or the new task was you need to develop and implement quickly a biosafety program. And you're responsible for that in this new section. And so that entailed, for me, learning a lot about biological safety and the different hazardous organisms and what it all involves. And the first thing I was able to do was hire a biosafety officer, really sharp guy, that came in and helped out in developing a institutional biosafety program that not only covered the biomedical facility, which was, involved at a low level, but also now we got into weapons and other parts of the laboratory programs that were looking at building a new higher hazard biological handling facility, as well as bringing biological samples in from various locations around the country, I assume around the world, for analysis to see what was on them. So that took some time, but in a 2-year period, I was able to pick up the needed knowledge, hire the right people, and we had a really good biosafety program that supported laboratory activities. It probably still is. I haven't checked, but it's an important component that we added at that time. And as far as that was just shows, if you're thinking, well, I got my industrial hygiene responsibilities all laid out and I don't have to worry about anything, I know what they are, management can come in and give you a new assignment. And you just got to say that's exciting. That's something that you get to learn and be able to handle.
Dr. Johnson, thank you so much for joining us today.
My pleasure.
That wraps up today's episode of the AIHA's Healthier Workplaces show. To learn more, visit the AIHA website and follow us on social media. Thank you for tuning in, and as always, remember that healthier workplaces mean a healthier world. Until next time.